All right, let's talk about something that's on a whole other level. We're moving way beyond just having a single AI coding assistant helping you out. We're talking about managing an entire factory of them. So today, we're going to dive into a pretty radical new vision for software development, powered by two really interesting tools, Beads and Gastown.
You know, you just have to start with this quote from the creator, Steve Yegi, because it tells you everything. This isn't about some gentle, polite AI assistant. Nope. This is about harnessing the raw, chaotic power of what he calls super-intelligent chimpanzees to build software at a truly incredible speed. It's a wild idea, so let's see how it actually works.
Okay, so this whole journey kicks off with a problem that, let's be honest, anyone who's used these tools for more than 5 minutes knows all too well. You give an AI agent a big multi-step task, and you come back later or it has to restart, and poof, it's completely forgotten the plan. It loses all the context, and your whole project just grinds to a halt.
So, how do you fix that? Well, the first piece of this puzzle is a tool designed to solve exactly that problem. It's called Beads, and it's built from the ground up to be a permanent, rock-solid memory for your army of AI agents.
And here's the core idea, which is pretty brilliant. Instead of relying on some messy markdown file that the AI has to try and read, Beads creates a structured graph of all the tasks. Think of it like a souped-up issue tracker, but one that's built specifically for AIs. And the most important part, the real kicker, it's all stored in version directly in Git, right there alongside your actual code. Let's just quickly break down what makes this so effective. First, using Git as the database means the memory survives everything, restarts, crashes, you name it. The whole system is designed for agents to talk to each other easily. And thanks to some clever hash-based IDs, you can have a ton of agents all creating tasks at the same time with zero conflicts. But maybe the coolest feature is something called compaction. It automatically summarizes old, finished tasks, which is a lifesaver for freeing up space in the AI's limited context window. Okay, so your agents have a perfect memory now. Problem solved, right? Well, not exactly. In fact, that creates a new, even bigger problem. Once you have more than just a few agents working together, you need a way to manage them. You need an orchestrator. And that is where Gastown comes in.
And Yegi, with his typical flair, frames the challenge perfectly. Think about it. Without some kind of system, having dozens of AIs all trying to merge code into the same repository, it just becomes pure chaos, a monkey knife fight. So the real question is, how do you turn all that chaotic energy into something productive?
And I mean, just look at this. The difference is really night and day. Before Gastown, your work is fragile, everything's manual. With Gastown, the work is persistent, the agents actually have their own identities and can communicate, and you can go from a chaotic handful of agents to a pretty productive team of 20 or 30. The whole state of the project is no longer in an agent's flimsy memory. It's saved securely in that Git-backed Beads database. So, how does this so-called IDE for 2026 actually work? How does it organize all that chaos? Well, it all comes down to a really clear hierarchy. You can kind of think of it like a real-world operation. You've got your main town, which is your entire workspace. Inside that town, you have different rigs, and each rig is just a single Git project. And then within each rig, you've got the workers. And yep, those are the AI agents actually getting their hands dirty and writing the code. And these aren't just generic bots. Each agent has a specific job. First, there's you, the human. You're called the overseer, and you set the big picture strategy. Your main AI point of contact is the mayor, who's like your chief of staff. Then you have polecats. These are awesome. They're disposable workers that spin up for one task and then just disappear. The refinery is absolutely critical. It's the air traffic controller for your code, managing the merge queue so you don't have that monkey knife fight. And then behind the scenes, you have the witness who watches the polecats and a deacon, which is the little daemon that keeps the whole town humming along. Now, the engine that powers all of this is a system called MEOW, which stands for Molecular Expression of Work. This is the real secret sauce. It's a way of defining any workflow as a series of small, durable steps that get stored in beads. The beauty of this is that even if one agent completely crashes and burns, another one can come along and pick up exactly where the last one left off. So here's how that works. It starts with a formula, which is basically just a recipe for a task. That recipe is then cooked into something called a proto-molecule. You can think of that like a master template that can't be changed. And finally, you pour that master copy to create a live molecule. This is the actual active to-do list that an agent can grab and start working on. Okay, so when you have a system built on these kinds of automated, durable workflows, it requires a completely different way of thinking. You just can't micromanage it. You have to learn to let go and embrace a philosophy that Yege calls vibe coding.
And I just love this quote. It captures the idea so perfectly. You're no longer micromanaging every single line of code. You're just slinging work around. Your focus is on throughput, on relentless forward momentum. Yeah, some work might get redone, maybe a few fish fall out of the barrel, but it doesn't really matter because you are shipping an absolutely enormous volume of work.
This is the key principle that makes all that chaos productive. Non-deterministic idempotence. It's a fancy term, but the idea is actually pretty simple. The exact path an AI takes to solve a problem is totally unpredictable. It's going to be chaotic. But because the task itself, that molecule, is stored durably in Git, the final outcome is guaranteed. Sooner or later, an agent will get it done. And what keeps this whole factory running 24/7? It's a dead simple rule programmed into every single agent. The Gastown Universal Propulsion Principle, or GUPP. It's simple. If a task is assigned to you, if it's on your hook, you run it. Period. No waiting, no asking questions. This simple rule is what makes the entire system autonomous. Now, I know this all sounds incredibly powerful, and it is, but, and this is a really big but, before anyone gets too excited and tries to download this, it is absolutely vital to understand that this system is not for everybody. In fact, right now, it's not for most people. The creator is extremely clear about this, almost screaming it from the rooftops. This is not some polished, user-friendly product. It is raw, it is complicated, and it is built for a very, very specific type of power user. And let's talk about the cost. Running 20 to 30 of the most powerful AI models all at the same time is, as Yeg puts it, a cash guzzler. This is not a tool for hobbyists. You need a pretty significant budget to run this thing. This is probably the most important warning of all. These are powerful agents that have direct access to modify your code. If you don't know exactly what you're doing, they can cause serious damage. This is a tool for experienced chimp wranglers and chimp wranglers only. So who is this actually for? Yege lays out this evolution scale for developers using AI, and he's crystal clear that Gastown is only for people who are already at stage 7, meaning you're manually juggling 10 or more agents, or stage 8, where you're so deep in this you're already trying to build your own version of this system. So what's the big takeaway here? Gastown gives us this fascinating, chaotic, and maybe even brilliant glimpse into one possible future for how we build software. It's a future that trades meticulous control for massive throughput. It's a radical idea for sure, and it leaves us with a really big question. Is the future of coding less about writing perfect lines and more about wrangling super intelligent chimpanzees?